Okay, so there are four definitions, as I said. This is section 4.2, and we're going to look at each of these. And tomorrow I'm gonna actually get you on the computers, and you're going to construct some of these. And I'll give you a preview of that today. But the first thing that I want to talk about is a median. So a median, the definition of a median is that it's a line segment joining the vertex to the midpoint of the opposite side, and this is talking about in a triangle. So median is related to a triangle. So if I draw a triangle, first of all, the median is going to be a line segment connecting a vertex. How many of those do we have? 3. A vertex happens at any of the angles, right? You got 3 angles, and you have 3 options. So I can pick any one I want. So let's say I pick this vertex here. We'll call it point A, and I need to connect that point to the midpoint of the opposite side. So if this is B and this is C, I find the midpoint of B and C, call that M for midpoint, and I connect A and M, and that's what we call median. So a median has to be connected to a vertex and a midpoint, and because it's a midpoint, it cuts these two in half. Does it split the triangle into 2 congruent triangles? Yeah? Why? By what? It shares a side, but we know nothing about the angles, do we? So median doesn't cut an angle in half. It just cuts a side in half. And so not enough information to say those triangles are congruent here. Okay, that's important to know. So median doesn't necessarily mean it splits into 2 congruent triangles. But that's what a median is. I'll show you. So tomorrow, we're going to play with a program called GeoGebra. Geo from geometry, algebra, GeoGebra, kind of combined. And you'll be working with some applets that look something like this. Let's go geometry. And you'll have these, let me make this a little bit smaller here. So it's on the screen, okay. So you'll have these pull downs here, and I'm going to make a triangle. And then I'm going to create a median. So to create a median, first we got to find a midpoint. And so you have these options here that will do some of the stuff for you already. You see right here, it says midpoint or center. If I click on that, it will quickly find a midpoint for me. And so I say, let's find the midpoint of that. And so I just clicked on the line, and it gave me a midpoint. And if I grab this arrow, I can move the triangle around. And no matter how I move that triangle around, it remains that midpoint. If I grab the midpoint and try to move it, it doesn't move because I find it as a midpoint. It needs to stay right in between the other two vertices. Okay? And so then all I have to do to create my mid segment is to grab a segment and connect a vertex to that. And then maybe you could see why those 2 triangles don't have to be congruent, right? So that median does not have to create 2. It can, but it doesn't have to. And this is definitely a picture of why it doesn't have to. Okay, so that's a median for you. Next one I want to look at is an altitude. So an altitude is a line segment as well. And it also has to, one of the endpoints has to be at a vertex. But the other vertex in this case does not have to be at a midpoint. The other vertex has to be, the other point has to be on a line containing the base, and the segment has to be perpendicular to that line containing the base. And that's a little confusing maybe. What does that mean? And let's take a look. If you have, first let's look at an obtuse triangle. Okay. Do you guys remember how to find the area of a triangle, the formula? Area is equal to 1/2 times base times height, right? So that height part is the altitude that we're talking about, okay? So we could say it's 1/2 base times the altitude. So we got 3 sides to a triangle. Any side could be your base. Typically, we use this right here as the base, okay? Let's say that's the base. And I find that that's the base of 2, and then I want to find the height of that triangle. How would I find the height of that triangle? What would I have to look at? Would it be one of the side lengths? No. What would you have to look for? What you would do is you would extend this base, and then you'd say, okay, from this vertex, you would draw something perpendicular to that, right? And that would be your height or your altitude. Okay, so with that picture in mind, we look back at our definition. Okay, the altitude is a line segment through a vertex, and it's perpendicular to a line containing the base, right? And so we could see that picture there. Now, does the altitude have to be outside of a triangle, every triangle? No. If the triangle is not obtuse, then the altitude is going to be on the inside. Could the altitude ever be a side of your triangle? If it's a right triangle. So if you have a right triangle, then this side right here will be your altitude. Okay. So the altitude in each of these pictures I'll highlight. Okay. This one is probably the to construct, and I'm going to have you guys constructing it tomorrow. So kind of watch what I'm going to do here and see if you can remember it for tomorrow. Let me undo what I did here. If I wanted to construct the altitude, and when you construct an altitude, first I'd say start with an obtuse triangle. It's easier to see it and work with it. But the first thing I'm going to need to do here is construct a line that goes through my base. Okay, so just to extend it, right? And then what I want to do is drop something perpendicular to that line. And we have some options here. We don't have any perpendicular segment options, but we do have a perpendicular line option. And I'm going to click that perpendicular line. So I want it to go through that vertex, and I want it to go perpendicular to that line. And so what's going to happen now, still haven't created it, but as I move this triangle around, those two lines will always be perpendicular to each other, okay? And one of them will always go through the base. And so I can work with that for our altitude. So altitude now, next thing I'm going to need is a point at the intersection of those two lines. And then I don't need those lines anymore. And so there is a thing that says I could show or hide an object, and I'm going to hide that line. And so now when I move things around, I got that point where I want it. And so I just need to connect vertex to that point, and that's my altitude. So that's the height of the triangle. You can see it's an obtuse triangle. This is when you have an acute triangle. And if you had a right triangle, these two would match up, create that right angle. Okay. So that's our altitude. Does an altitude have to be a median? No. Could an altitude be a median? Yes. If the altitude is a median, what kind of triangle are we going to have? Isosceles. Right. And you can prove that. because this would be congruent to this. These two would be 90. This would be congruent to itself, so angle side angle. And then we can say this is congruent to this, and we've got a nice isosceles triangle. Okay. All right. Next one, angle bisector. We have worked with angle bisectors in the last unit. So an angle bisector, notice though, is not a line segment. It could be a line. It could be a ray. It could be a line segment. Okay. But what's important is that it divides an angle into two congruent angles. So we don't even need a triangle here, but we're going to work with triangles. And so if I have this triangle here, and I pick an angle, so I say angle A here, and I just draw a ray that cuts that angle in half so that this matches this, then let's call this AB. So then ray AB would be an angle bisector. Those are angle bisectors are really easy to on this program, and let me just show you real quick. There are harder ways to construct these, obviously, but we're going to use the built-in programs here. There is something that, if you look at some of the options for the drop-downs, you have something called an angle bisector. So you don't have something called median or an altitude, but you do have something called an angle bisector that you can use. And to use that, you're going to select 3 points to create that angle. Okay. So, for example, if I want to work with this angle right here, then I'm going to go point, point, point. I'm going to make this my middle selection, just like we would with 3 letters. And then it creates something that cuts that angle right in half. And so then if I have a small angle, cuts it in half there, and no matter how I move it, it will always bisect that angle. Okay. And then the last thing, perpendicular bisector. Perpendicular bisector does 2 things. Okay. First of all, perpendicular bisector bisects. It cuts a segment into 2 equal parts. Second thing, it's perpendicular to that line, right? So perpendicular bisector it looks something like that, right? So take a close look at the definition of a perpendicular bisector and answer this question. Could I say that a perpendicular bisector is a median and an altitude? So first of all, is a perpendicular bisector a median? Is it connected to a midpoint? Does it have to be connected to a vertex? Does it say anywhere in the definition that has to be connected to a vertex? Okay. Also, why else is this not a median? It doesn't say it has to be a line segment. It could be a line. So let me show you another example. Here's a perpendicular bisector. Perpendicular, and it bisects, but it does not have to go through a vertex. So a perpendicular bisector could be a median, it could be an altitude, but medians and altitudes are segments, and they both have to touch a vertex. A perpendicular bisector does not have to touch a vertex. Okay, and that's really important that you know that part. Okay, and then constructing these, let me just show you that real quick as well. This one's also an easier one to do. So there is an option for perpendicular bisector. So it's a common thing. And so I could select that, and I could select the segment I want to right there. So that's a perpendicular bisector. Cutting that segment, and it's always perpendicular to that segment, no matter how I move that triangle around. All right, there we have it. Okay, so that's the new stuff for today right there. The rest of the stuff is going to be you and working with these definitions. I have, again, the midpoint formula here. You guys used that on the last homework, but I just want to mention a couple things about it. First of all, midpoint, you have 2 points. The midpoint is the point right in between them, as you guys know. And so that these two, it would cut that segment in half. And what's happening in this midpoint formula? What is it? If you take a look at this, if I want to find the midpoint for the x-coordinate, I take the first x value and the second x value, I add them together and divide by 2. What is that when you add two things together and divide by 2? What are you finding? What's that? The mean. Yeah, that is a way to find the mean, or some may say the average of two numbers. And the mean and the average is actually a middle, right? It's what's right in between those. And so it makes sense that the midpoint would use something like that. And so really, I want you to see that the midpoint formula is just the average of the two x values and the average of the two y values. Okay. The distance formula. I'm just debating whether I want to go into it or not. But I'll give you a little background. The distance formula comes from Pythagorean Theorem. Here's the idea. So I have 2 points. I want to find the distance between those 2 points. And so we say, well, I'm not sure how to do that, but I could make a right triangle. And if I make a right triangle, if I could find this distance here, which is, I'll call it A, and I could find this distance here, which is B, then I could find the distance in between them, I'll call it D. You might be used to C. But it forms a right triangle, and we can use Pythagorean Theorem, which says that D squared is equal to A squared plus B squared, right? You guys follow me? And so if I wanted to solve for D, what would I have? How do I get rid of the square? It'd be the square root of A squared plus B squared. And so if you look at our distance formula, this is our A squared right here. This is our B squared right here. So what's really happening is you're finding the difference between the two x values. This is your horizontal distance. That's A. And the y1 minus y2 is just the vertical distance. That's your B. And so it's coming directly, it's how you'd use Pythagorean Theorem with coordinates. And that's what it ended up looking like. So I just want to let you know that's kind of where it's coming from. And that's all I want to say. You do want to have that memorized and be able to use that, okay? God bless you. For slope, there's the formula, but I just want to say a couple things. One that you saw in your homework, that two lines are parallel. If they have the same slope. And they're not the same line, okay? But I want to add the other part. Two lines are perpendicular if their slopes are what? Sorry, I should be I before E. Yeah. If their slopes are what? Anybody remember? Yeah, Leah? Yep, so opposite in terms of sign. So one's positive, one's negative. Not only that, but reciprocals. So opposite reciprocals. Okay. So let me give you some examples. So if one of them has a slope of negative 1/2, what would the opposite reciprocal of that be? Positive 2/1, or positive 2. If one of them had a slope of -3, the opposite reciprocal would be positive 1/3. If one more, let's do one more. If one of them had a slope of positive 3/5, the opposite reciprocal would be -5. Okay, so keep that in mind, because in homework tonight you're going to be asked to verify that things are perpendicular, and so you're looking for opposite reciprocals. So let's, we got a few minutes. Let's start the homework together. Okay, get you a head start, and let's work with the proof real quick. Okay. So, number 1, part A, it tells us that BC is an altitude of ABC. Let's just work with that part. BC is an altitude of triangle ABC. Take a look at the picture and think about what that says. What does that really tell us? Think about the definition of an altitude. What does it mean in this picture? Here's, I'll highlight BC. BC is an altitude of ABC. It tells you it's a right triangle because a side length is actually the altitude, so this is a 90-degree angle, although it doesn't look like it. It's not drawn to scale, but that's what that's telling us. Okay. Also tells us that AD is an altitude of ACD. So that's kind of the same information with the other triangle, so that gives us something here. And lastly, AC bisects BAD. And so an angle bisector gives us two congruent angles. All right. So now to our proof. We have the given, and then we got to fill in something for 2. And 2 relies, we know, that on the definition of an altitude. So what should I put for 2? Yeah. Well, is that the definition of a altitude? Does it say? We know it is, but I don't think that relates to the definition. Look ahead a little bit in that proof. You guys figure out what we should put for 2. Okay, these 2 angles are congruent. We want to get there, but I think we're going to have to wait till we get to 4 for that one. Okay, so that's where we're headed. That's good to see that. Yeah, Suzuka? AB is perpendicular to BC, and CD is perpendicular to AD. Because that comes from the definition of an altitude. Altitudes have to be perpendicular to a base of the triangle. That we can get, right? We know, we're thinking down the line, yeah, these are right triangles, but we can't get there without these steps, okay? So then, because they're perpendicular, well, what is the definition of perpendicular? They're right angles. So we could say angle ABC and angle ADC are right angles. And some of you might be saying, well, we already did that. It's in our picture. And that's true, but when you're writing a proof, you have to kind of slow yourself down and say, why is that in my picture? Okay? And that's what we're doing here. So because of this is true, why can we say that those 2 right angles are congruent? Yeah. All right angles are congruent. Good. And then we want to put something for 5 that relies on the definition of an angle bisector. Elijah? Good. We're not sure what to put for 6, but if we skip ahead to 7, we know where we're headed. And I guess you guys got to finish that for homework. All right. See you guys later.